So in this last video for the special right triangles, I'm going to run through page 2, which starts off with something called a summary table. So basically, if we look at what we just found in the last video, we know that the sine of 30 is 1/2. The cosine of 30 is root 3 over 2, and the tangent of 30 is root 3 over 3. 45-degree angles, sine was root 2 over 2, cosine was root 2 over 2, and tangent was 1. And last but not least, 60-degree angle, sine of 60 is root 3 over 2, cosine of 60 is 1/2, and tangent of 60 degrees is root 3. I would recommend that you get very familiar with this chart in this order. So do something, practice this to make sure that you're going to know these pieces in these places, because as we move into further and further into this semester, this is really going to be the foundational piece for a lot that we do when we move into something called the unit circle and solving equations. So make sure you learn this in some way, shape, or form. A couple things. All the denominators for the first two lines are 2's. And if you can count, this is 1, 2, 3, 3, 2, 1. All right, that's the best thing I can help you with to start learning those. All right, so a couple of quick examples, kind of like what I did in the proof part of the 30, 60, 90s and 45, 45, 90s. We're looking for missing information. So here's what I know. Opposite the 30 is x. The hypotenuse is 2x. Opposite the 60 is x root 3. So if x is equal to 9, that's going to make this side 9 root 3. And it's going to make this side 2 times 9, which is 18. And that really is as simple as it gets for that problem. All right, as long as you can label your sides and figure out what x is. Number 2, it's part 2 of problem number 3. We've got a 45, 45, 90. So we've got x root 2, which means that this side, these two legs are the same. So y is 73. And whatever your leg is, we're going to multiply that times root 2 to get the hypotenuse. So that one's all done. All right, part 3 here. Well, we're missing a little bit of information, but it's pretty easy to figure out. If this is 60, this is 90, there's got to be a 30-degree angle sitting here. So this is x root 3, and 2x. Now, if you can notice that this is x root 3 and this is 6 root 3, that means the x has to be 6. So this side over here across from the 30 has to be 6. And now that you know this side, you can figure out the hypotenuse. So 6 times 2 means the hypotenuse is 12. So double it up. All right, so that's the examples for the 30, 60, 90s, 45, 45, 90s. And the last quick questions here, they look really straightforward. You just want to be careful because what we're looking for A, B, C, and D here are, find the following, exact values. All right, so be careful with this. Now, I'm actually going to use the chart at the top, so I'm going to try and keep the picture. All right, there we go. So secant is the reciprocal to cosine. So if I know that the cosine of 60 is 1/2, the reciprocal to that would be 2. So the secant of 60 is 2. The cosecant of 60, well, that's the reciprocal to sine. And my sine is root 3 over 2. So if I do the reciprocal of that, that would be 2 over root 3. Well, I need to rationalize that. So be careful when you do this. It's going to be 2 root 3 over 3. Okay. I know I'm running the rationalization relatively quickly, but it is what it is in terms of just multiply by whatever it takes to get rid of the root in the denominator. Okay. Cotangent of 45. Well, cotangent's the reciprocal of tangent. And the tangent of 45 is 1. Well, the reciprocal of 1 is 1. That was easy to work with. All right, and secant of 30. Well, secant of 30 would be the reciprocal to cosine of 30. Cosine of 30 is root 3 over 2, so the reciprocal would be 2 over root 3. Rationalize that, just like we did in cosecant of 60, and that's going to be 2 root 3 over 3. So you will be asked to find exact values, and if you were to try to put these in a calculator, they end up getting decimal values, and because they have radicals in them, you're not going to be able to have your calculator necessarily convert from the radical to the decimal or decimal to radical. All right. So if you have any questions or concerns on any of these problems, let me know. Other than that, that is going to be the